Hello everyone, it's September 11th. Alright, we had a bad streak, 2 days. Didn't do very well, but we're still going to do it today. It's not like I'm going to give up. It's not going to scare me, right? It's not going to scare me. Let's do this. Basic calculator. Okay, doesn't seem to be that hard. I think all we need to do is parse it, right? Alright, given a string representing a valid expression, implement a basic calculator to evaluate it. And return the result of evaluation. You are not allowed to use any built-in function which evaluates strings as mathematical expressions such as eval. I think this is exactly what I'm going to do. I think what we can do is just return eval s. Not sure. Let's try it. Okay, let's try a more complicated one, like this. Yeah, I know it says that do not use eval, but who cares? Let's just eval it first, just to pass it, for the lols. Oh wow, they. Oh, nice. Okay, how many do we pass? I think they added that specifically to prevent you from using eval. I have to deal with the laptop again. 36, or past 36, so it's in number 37. Alright, that's just for fun. Alright, let's not do eval. Okay, evaluate it. I think we can just use a stack. 3 times 10 to the 5th, plus minus parentheses. And, oh, they have a empty space. Plus, it could be used as a unary operation, but it has to be inside parentheses. Ooh, interesting. Note 2 consecutive operators in the unit input. Every number return character will be fit in a sign. Okay, so we're gonna have empty space, and if it's a plus, it's not a unary, so it has to be 2 things plus, but as a minus, it might be for a single value. So what we're gonna do is using a stack. So I'm looking at this, so push 1, push plus, I think we need to push plus, and then push 1 again, and when we push a value, we check in the previous one. If the previous one is an operator, then we pop the operator and we know what this operator is, and then we check the previous value. And when we compute a new value, we push it back in. So this will be 2 in first, and then minus, right? Minus, when we hit a minus, because it can be unary, what we will do is we are going to look at the previous. Oh, but pay attention. Pay close attention that it is possible to. Ooh, this is actually interesting. Because we can have a sequence of number, right? It's not just going to single value. It's going to be more. That is interesting. So we have to, as we go through this, it has to be keep counting until we reach a separator, either a plus or minus or an empty space, right? So let's say we have a minus sign. Okay, so we have a minus sign, and we look into the stack. And in the stack, we see there is a number. So we know this minus sign must be used as an operator. So we actually don't have to push it in. Yeah, whenever we hit an operator, right, there gotta be something already in the previous. Otherwise, it's not going to work. So it got to be something already computed. So when we hit an operator, we hold it somewhere else. Hold it somewhere else. And then we keep checking for the number, right? And when we have a number, then we check if we have an operator waiting for us. And if an operator is there, we are going to compute the value. So let's say we have a minus, right? And we check, and we check on the stack there is something, so the minus is going to be an operator. So we put minus in the operator stack. Next one we check is 1. We got a value of 1, so a value of 1. And when we get a value, we first check the we first check on the operator. An operator is a minus, and we have an operator. Then we pop something out, 2 popping out. So we do 2 minus 1. We get 1 pushing into the stack. And now next one is plus. Plus we can just go into the operator. The current operator is plus. And next one, 2 comes out. So 2 is a value. We check on top of the operator, we get a plus. And then we check on top of the stack, we get 1. So 1 plus 2 will be 3. We push into the stack. And we end, we pop the stack, we got 3. All right, let's try the last one. So we have parentheses. So parentheses in, 1 in, plus on the stack, parentheses in again, 4, plus in the stack, 5, took in the stack is a plus, so 4 plus 5, we get 9. Next one is plus, next one is 2. 2 is a value, look into the operator, operator has a plus, pop it out. 9 plus 2 now become 11, push it back in. Now a right parentheses. When we have a right parentheses, we're going to pop things out until we hit a left parentheses. So we pop it out. So when we have a left and a right parentheses, right, everything inside shall already be computed. That's what we think. So we pop out. So 11, pop out, we're going to hold. We hold at 11, and then it should only be 1 value. If we have more than 1 value, then we're wrong. Yeah, and then we pop, pop, pop. So we'll have a left parentheses, and then we pop out. And that's it. Oh, is that it? Oh, yeah, so we pop out 11. Actually, when we pop out 11, the value we can throw back into the, and we can make this as a deck. We're going to put 11 into the front of the deck, right? I push the front of the deck. And then, when we get the left parentheses, we're done. And then we check on the deck again. That's first thing come out is 11. 11 is a value. We go for the operator as a plus. Now we got 12. Okay, now we got 12. Next one is a minus. A minus, we look, we have a value, right? We have a value, so minus is going to be an operator. Actually, what we can do, just every time we see a negative, we just push a 0. Right? We can push a Z. Let me think. No, we gotta check. Check has 12, so it's gonna be an operator. And then we push it in. And next one is 3. 12 minus 3 is 9. Right? And then we have another parentheses. So we have parentheses out. So we pop the value, put it into the deck, and next is a left parentheses. We annihilate. That's it. Right? And then we push. Now it's 9 plus sign, and left parentheses, right, 6 plus sign, 8. 8 will be 14, right, parentheses, pop out, push in, annihilate, 14 comes out, plus 23. Okay, let's just follow this and see what we get. I think this is solid. I think this is a solid plan. A little bit, I won't say complicated. It's interesting. I think it's an interesting problem. And of course, we have to do, and we need collection. Yes, we need deck. That's exactly what we want. So we have this, and no eval. So basically, we're going to turn this into a deck. We can pre-process it. Let's pre-process it. Just make sure each one will be so we can. Yeah, let's pre-process. Let's say input. Oh no, okay, now you input. Let's say deck equals deck, right? And then for letter in S, right? What do we do? If letter is equal to a this, then continue. We continue, and if letter in left parentheses, right parentheses, plus or minus, right? Then deck dot append a letter. And if, right, else, so letter is a digit. Right, when it's a digit, we're gonna keep reading until, oh, keep reading, you say. Keep reading, you say. That is an interesting thing that you're doing right here. So I think, wait a second. How can I grab the numbers out? We can use regex to grab the numbers out. Think about it. Regex, right? We use regex to grab the numbers out, and then how about the order of the of these things? Let me think. What do we want? Right? What do we want is, now I think regex might be more complicated. You know what? Let's do this. I is 0. I just stupid way, right? Stupid way. And while I is smaller than len s, right? Stupid way. Let's just do one by one, right? Say if si is this, continue. No. I plus equal 1, continue. If si is in this, put in this one. You know what? You probably don't even need this. Just say if s is in this, then else, blah blah blah, blah blah blah, and eventually I plus equal to 1, which means aleph si is a digit, right? Digit will be this, right? It's a digit. Then blah blah blah. If it's empty, it's a space, then we just keep going. Now, how do we handle this? Now we need another one. How was it? Wonderful. Let me say what do we have here? What do we have here? And I want it to be Now it could be a mixture of things, doesn't really matter. So make it all strings. Can a deck be, it can be mixture, right? Hold on. A deck can be a mixture. Collections, import deck. Right, so A equals deck is, right, A dot append, I can append the numbers, and now I can also append a string, right? And then I can say for B and A, print B equals 1. Yeah, I think that's fine. So what I'm gonna do is while J equals, let's say J equals, let's see. We can move I. That's fine. Yeah, we can move I. We say while is I. While this. No. I feel we can. If it's this, right? If it's not this, so while is this, right? While it's this, and then we're gonna do temp equals J equals I. No, J equals I plus 1. And while Sj is in this J plus equal 1 until Sj is not. But yeah, I do think, let's just go here is equal to empty. And we just ignore it. I plus equal 1. I was trying to write it the best way possible. This, I like how this one's going. If it's not this, and if it's this, we append, right? And then else, right? We do this, J equals this, and a while this is this, J plus equal 1 until J is not, and then deck dot append Si to J with J already plus 1. So we do not include a 1 that does not belong to the number. So append this, but we're going to int it, right? We're going to int it. Now once we append that, then our job is done on here, right? Our job is done. Deck append. Once we're done, what do we do? Well, actually, I equals J minus 1. Right? And then, because it come out, we have to do I plus 1. So do that. And then we actually want to give us, so transform, right? We can call it transform as, this is going to come out as a deck. I don't want to do this. So basically we're going to do this. The entire thing is transform and return deck, right? So when you say deck equals self.transform s, right? Now I get a deck. Next step is to have a stack. A stack can just be this. We have two stacks. We can say cal s and operator op, right? OPES, right? Two stacks. And then we're gonna say while deck, and then current equals deck.pop left, right? So in the pop left, and we say if current in this, I can just say equal current equals this cal s dot append current aleph, bless you, equals a plus sign, right? A plus sign, then operator dot append current, right? So these two are straightforward. Aleph, now we're gonna handle current equals minus sign, right? If it's a minus sign, then it depends. Depends on what? Depends on if the previous one, it says could be used as unit operator, but it has to be inside parentheses. So it doesn't matter. So all we need to see is whether we have something in the stack. Right? I'm gonna say if stack and stack last one is a digit, the number. So I think it's number, right? Not sure. We have is number. No, I don't think it says number. Is I'll no. How do we check if it's a number? Good question. No, I think it's a string, right? If I say 1, 2, 3, 2, 3, a dot is, yeah, is alpha, is digital. So that means we don't transform here. It's going to be all strings. It's going to be all strings. Yeah, let's try. Let's just all strings. So we're going to be all string. Then we can check. All right, we can check. We're going to say, stack this, right? Dot is digit. Is digit. If we have a stack and it's a digit, if that's the case, then it's going to be an operator. So we're going to append current. Else, either if it's nothing in the stack or the stack is not a digit, then we are going to append, right? We're going to say stack dot, let's say cal stack. This is no stack. Jeez, man. This is cal stack, calculate stack. So we can put dot append a 0 into it, right? When append a 0, and this is gonna go in there. So in that sense, what are we doing? We're gonna say if not cal stack or not is digit, right? Either the stack is empty or the stack top is not a digit, then we're gonna put a number into it, and then we're gonna append the current. All right, and append current into. So these two can be combined if this is this, or current is equal to plus, right? And oh, hold on, they cannot be combined. What are you doing? This is a cow. This is an operator. That's different. So minus we have handled, right? Next, LF current is that is digit, right? So current is a value. And now if it's a value, what we do is, again, we check the cow. We say if not cows or if not capital step is empty, we push it in. If it's not a operator, but there's no operator. Hold on, why do we need an operator stack? Well, you just push it in, right? What's the fuss? We don't need an operator stack. We should just push in, and then we can pop it. It's fine, because you have to pop it in anyway, right? Push and then yeah. I don't understand. I don't understand. We just need a single stack. And I like to call it stack. No. Let's redo this. I don't think we need it. I just need a stack. So or current is equal to a plus sign, and they both has a stack dot append. So we don't need this. If it's this, and we say if not stack or stack is not a digit, right? Is not a digit, then stack need to append a digit, and then stack append the current. Now, if the current is a digit, now if it is a digit, then I just realized something. I just realized we don't have to be. This doesn't have to be a stack. All we need to do is just reverse it. Right? All we need to do is just reverse it. And let's just try this one first and then do the other. So LF if current is a digit, right? And then we're gonna look into the stack to see the top of the stack if it's an operator, right? If it's an operator, then we pop this and then get the next one will be a value, compute, and push it back in, right? If it's not an operator, then we push the value in, right? So if not or the stack top is not an operator, so if not stack or stack -1 not in plus or minus, right? That means it's not an operator. Let's just do in. I like in better. Which one's faster? I think they're the same. That'll be fun. I think that'll be more fun. If it's not in this, if the stack is not in, so it means if there's no stack, or the top of the stack is not an operator, then we say stack.append current. Right? Else, so we have a stack, and the stack top is an operator. Then what we're gonna do is gonna pop the stack, right? And then pop the stack, do the operation. So the operation, we do need an operation. Let's say OP equals plus, right? Plus gonna be add. So we're gonna import operator. I think we have this thing. I'm not sure. Import operator. Operator dot add. Oh. Yeah, we have add minus subtract sub. yeah, so we're gonna say operator dot add. Well, it's gonna be lambda AB operator add AB, and then minus. It's gonna be a lambda AB operator dot sub AB. Alright, so this is our operation. Now here else, what we're gonna do is stack dot append, right? OP. Oh, who's gonna get popped out first? Operator. OPS is OP equals stack.pop, right? And then you can say OPS, OP, this gonna be stack.pop again, that's the previous value, and the current value. What's the current value? Current value is current, right? It's current. You know what? Let's do int here, so we don't have to do int the other side, because we say that A and B will both be digits, a string. So we append, we'll stack pop first, and dot append, gonna pop again, and after pop, this result, we append into it. That's fine, right? That's fine. Now, we have to handle the last part. It's a digit, right? It's a digit. If it's an operator, we do it. If it's not an operator, then we just append it. So that's that. Elif current is equal to the right parentheses. So if it's the right parentheses, now I have work to do. So if it's a right parentheses, what's going to happen? I mean, if it's a right parentheses, if we handled everything, right, then it should be just a value. We tried it first. We tried it already, right? So these, they will compute, put a value, they will compute with a single value. So if it's a right parentheses, all we are handling is just two things, right? Two things. And this thing, we actually need to push back into here. But in order to do this, we'll push this back in. So if it's a right parentheses, then we know that there must be a value in front of it, and there must be another one in front of it. So what we're gonna do is we're gonna do dec.append left, right? Append left. Oh. We have turned this back to str. Man, this is not what we want. Hold on. How do we check if it's a number? A equals 1, A dot. Conjugate from bytes, number real to byte. I don't think there's anything. How do I check? I mean, it's gonna be not false, right? How do I check that a symbol is actually a number? Yeah, I just realized it's gonna be complicated if I don't do it that way. Let me search. So Python check a variable is number. Check if a variable is a number. Oh, should go to Stack Overflow. I don't want to try except. That's stupid. Is instance. Is instance sounds like a good way. Let's go Stack Overflow. Let's see. Is instance. Yep. Nah, rejects is stupid. Is instance. I think that's what I'm gonna do. So is instance, let's say a int. That's true. Yeah. And ours is all instance. Ours are all integers. Yeah, so integers. So in that case, we're gonna int here. Right? We int here, and then we don't need to int here. So all these can go, and this one will return int as well, which is fine. And this is gonna be is instance, right? Stack this, and we're gonna say int or not. If not stack or not, right, is not an int, then we're gonna append a 0, append a number, right? And then we append this. If this is digit, which means if it is instance, right? If it's instance, not stack, it's current, is this. If not stack, or stack this is not an operator, we're gonna append the value. Otherwise, we're gonna pop it to get operator, and we're gonna do the operation. And stack.pop as another. It's gonna be the int, compute an int, we push an int in. That's good. We can do that. So this is gonna be append, right? With right parentheses, we're gonna say stack.pop. This is gonna be the value that's currently at the top. After do that, we're gonna say stack.pop again. That's pop the left parentheses, right? And once we do this, we go to the top. That's gonna be a value popping out. So blah blah blah. When we're done, we're gonna return. Oh, hold on. I say while deck, right? So pop out. It's gonna be a value, right? It's gonna be a value. Oh no, it's a deck. Wait, I would pop everything from deck, and then we return stack 0. There's only one value in the stack. All right, let's give this a shot. We have 1 plus 1, return 2. We have 2 minus 1 plus 2, 3, and I just copy this. This will be a 23. I actually have one more. So we submit it. Yeah, whatever this thing is, it's a gigantic. All we're gonna do is, oh, hold on. So it's gonna be this, and I don't know the results. Let's put a 0. S, yeah. It's gonna be calculate S. Run it. Depth is not defined. Depth Where? Oh, that's stack. Let is not defined. Oh, there's no let. It's si. Index out of range. Oh yeah, while j is smaller than ns, and pass. The last one, we need to compute this. I'm not sure. Let's take a look. And then code. See if we got this one. Invalid test case. I think it's required to have double quotes for string. Minus 56. I'm pretty sure we probably got it. Look at the way I'm talking. All right. I used deck. I could have used. Let's not use deck. I think we don't need to use a deck. All we need is just a stack. It's just a. That's going to be a stack as well. We're going to call it a stack, right? And then all here is going to be stack, but we're just going to return in reverse it. I have to reverse it, and then reverse it. We can pop it. So we're going to say this is going to be oh, what do we call it? We call it. So hold on. Hold on. I'm gonna do G, and then G. We're gonna do reverse S, right? And then this is gonna be pop, right? And then reverse is gonna be a pound. Okay, run it. Yep. Is it possible? I'll reverse it. We can reverse the S if you like it. If we reverse the S, I mean we have to reverse something. So either yeah, let's try not to use that. Code. Find any other test cases. 1, right? So like a single value. Is this valid? Oh, it's valid. Oh, here. This is like -2. This is allowed. Okay. How about and go for it. Submit. Pending. Oh, that's a long pending. Oh, we got accepted. I'm pretty sure this is not a hard question. I think they moved the hard question from Saturday to Friday. This does not seem to be a hard question. There is no specific trick, right? We first transform. We first transform the original string S into a stack, right? Where we parse. Yeah, we parse. We transform. Yeah, where we eliminate all the white spaces and turn each number, right? And convert each number token, right? Yes, that's what it is. It's tokenization. Yeah, this is tokenization. This is tokenization. I'm learning about this these days. It's a tokenization, right? We separate out. We get rid of the useless information like the empty space, and then we get the operator, the parentheses in, and finally we tokenize all the digits, put them together into number, right? And convert each number token. Right, and then we reverse this stack so that we can perform all operations on its tail. Then we build another stack for computation. The rule is if we encounter, right, a left paren or plus sign or plus, we push it into the stack. If we encounter a minus, right, minus, we first check whether there is any number in the stack, whether top of stack is a number. If it is, the minus must be an operator. Otherwise, the minus is a unary operator, in which case we simply push a 0 to the stack and then put in this stack. And then we push the minus onto the stack as well. If we encounter a number, we check top of stack as well. If it is an operator, we perform operation with the number that is second to the top on the stack. Then push the result back into the stack. If the top of stack is not a number, we push the current number in. Finally, if we encounter a right paren, it is guaranteed that the top 2 element of the stack is left parenthesis and then is the top of stack is a number and second top a left paren. We pop the top and push it to the reversed, the transformed stack, right? Push it to the transformed stack, and then pop the left paren. Then we continue. This probably is the only trick, right, involved. And it runs in ON because at most everything gets done twice, but normally it's not going to be done twice. So for ON, and let's check the runtime. I like to just push this. Alright, basic calculator. Oh, pretty bad runtime. 168. 168 milliseconds. 17% ranking. Alright. What are the better results? Better way to do it? 71. Or twice as fast. Oh my, look at this. I go directly at it. Let's see. If I is digit, we keep a number. If I is in this, number times sign times stack. If I is this, sign this, otherwise this will reset num. I don't see pop. Oh, this is an interesting solution. Okay, if I is digit, that makes perfect sense. If I is this, so the current is this, so result plus equals to the current number times the current sign times top of the stack. Yes, top of the stack. It is huge. What is top of the stack? And we reset sign and reset number. So because when we encounter this, right, we have a number. And if it's this, stack dot append, sign times stack times 1. If it's this, result plus equal to number times sign times stack. I didn't understand. I understand this part, right? All right, let's take a look. What is the example? Probably inside one of the solutions. That's easier because I have to go twice, and we have a reverse. You know what? You wanna try? Yeah, I wanna see. I want to see if it's actually faster. Let's try the deck. So we have a deck, right? And then blah blah blah, and then we can just return this. And then it's gonna be deck. Let's call it deck. I like to call it deck. It's a deck. And then return this deck. And while deck dot is gonna be pop left. And blah 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 here. Deck dot append left. Let's try it. Let's see if it's this example. I mean, at least we don't have to reverse it, so I think that might make it a little bit faster. Alright, let's try it with a deck. Probably not. It's the same. It's the same. we have a solution for this? Yeah, this is a medium question. Maybe they swapped. I don't know how I feel about this. Oh, it's labeled as hard. Man, comparing this to yesterday, actually yesterday is not hard. I have to say, yesterday is not hard. I was very close. Okay, it was difficult, but compared to some of the other hard questions, it was not that difficult. But I was very close to solving it. And today is the path that the path is very clear. That's all I can say for today. It's a very clear path. It's just I don't know. It's a clear path for me to solve today's problem. Like we have step by step, right? We're very clear what we're doing. Yesterday was not. Yesterday was we stumbled, right? We don't know which direction to go. And the day before yesterday, which is supposed to be a medium question, but we got stuck as well. 18 lines of. When did you write 2015? 2018 as the last edit. Okay, keep a global running total and a stack and assigns. One for each open scope. The global outermost sign is +1. Each number consumes a sign. Each plus or minus causes a new sign. Each this duplicates the current sign, so that it can be used for the first term inside the new scope. That's also why I start with this global sign 1 and a duplicate to be used for the first term. Each this closes the current scope and thus drops the current sign. Alright, I can't. I have to. So sign stack. So we had 3. So this consumes a sign. Alright, and then on negative, get a new sign, and then a left parentheses duplicate a sign. Number consumes a sign plus. Why is it -1? Why a plus? Huh? What is this? Plus or minus causes a new sign.